Alexander is recovering from a wild night out celebrating his 19th birthday. He is concerned that his liver is damaged. How can we find a way to help Alexander make good life choices in the future? We know that catalase is one of the enzymes involved in the breakdown of alcohol in the liver. Specifically, it breaks toxic hydrogen peroxide into water and oxygen gas, two components our bodies can actually use. By examining the reaction of catalase and hydrogen peroxide in a closed system with the addition of ethanol, the 2-carbon alcohol found in alcoholic beverages, we can determine the effect of Alexander's wild night of drinking.
Our hypothesis is that as the volume of ethanol is increased, the oxygen production will decrease. This is because we think that catalase is able to break down ethanol. This means the ethanol will competitively inhibit the catalase breaking down the hydrogen peroxide and less oxygen will be produced. Our reaction chamber was first prepared by first affixing a paper disc soaked in catalase to the wall. Next, 10 milliliters of hydrogen peroxide and 10 milliliters of water were added to the bottom of the reaction chamber so that they did not touch the paper disc. The chamber was plugged and submerged in a tub of water. A graduated cylinder filled with water was placed over the reaction chamber's opening. The volume of oxygen gas that was collected in the graduated cylinder was measured every 60 seconds. This procedure was repeated with a 5 milliliter water and ethanol solution, and then again with a 10 milliliter ethanol solution. Each of these trials was also repeated 2 more times to ensure accuracy.
We collected data from 3 replicates of each trial. We tested the catalase's ability to break down the hydrogen peroxide when the reaction chamber contained 0, 5, and 10 milliliters of ethanol. Our observations supported our hypothesis that the addition of ethanol would reduce the amount of oxygen gas produced. As you can see, as the volume of ethanol increased, the average rate of oxygen production decreased.
The results of this experiment are consistent with the initial hypothesis. They indicate that ethanol inhibits the breakdown of hydrogen peroxide by catalase. The results do not give enough information to determine how ethanol is inhibiting the enzyme.
So we further analyzed what was happening on the molecular level. Normally in the body, hydrogen peroxide is oxidized by catalase into water and oxygen. The same reaction in the presence of ethanol will yield water and acetaldehyde. No oxygen gas will be produced in this reaction.
After researching the reactions that occur with catalase when ethanol is present, it is now clear that the initial hypothesis is not actually correct. When ethanol and hydrogen peroxide are in the presence of catalase, they are broken down into acetaldehyde and water. During this alternative reaction, hydrogen peroxide is still broken down, but no oxygen gas is produced. Since oxygen produced was used to measure the rate of reaction, it appears as if the rate of hydrogen peroxide decomposition was decreased, when in reality, hydrogen peroxide was still broken down at the same rate. This shows that ethanol does not affect the activity of catalase.
As previously discussed, our experimental design did not actually record the dependent variable common in each trial. To improve the experiment, we could record the change in volume of hydrogen peroxide to see how much of the reagent is being consumed in the reaction.
Given that we now know that ethanol leads to the production of toxic acetaldehyde, we better understand how alcohol negatively affects our liver function and causes damage, such as cirrhosis. This will be useful in better informing people, such as Alex, who consume alcoholic beverages, and will hopefully help them limit their intake, so as not to cause permanent damage to an organ that we require so much from.
Since the experiment showed that ethanol interacts with catalase, and background research showed that it breaks ethanol into acetaldehyde, the next practical question that this experiment raises is how does acetaldehyde affect the liver? The logical next experiment would be to test whether acetaldehyde damages liver cells in order to find the answer to Alex's original question of what alcohol's effect is on the liver. Ultimately, although alcohol may not inhibit catalase activity, it can still cause damage to your cells and creates products like acetaldehyde when it's broken down. Maybe Alex shouldn't have had such a crazy night after all.